Hey guys, thank you very much. I'm Greg Hoffer, VP of Engineering at GlobalScape. First and foremost, you have my permission to record if you want. I honestly don't think I'm that interesting, but if you're like my kids, you record everything and post it on YouTube and try to make millions of dollars, so have at it. Thank you for taking the next 45 minutes to share a discussion with me around the perilous journey that data takes through IoT. What I'd like to offer is that this is a data-centric view of IoT security, which is a slightly different perspective than a lot of other IoT conversations here at RSA, which is more device-specific or endpoint security. So I'm going to just start with this general expository question here. How many of you out there have on your person or with your person or maybe in your person 5 or more IoT devices? Wow, we do have some. I figured we get 0. How about 3 or more? 3 or more? I'm not even going to go with 1, right? I picked odd numbers, but I'm not going to go with 1 because we all have a tablet, a computer, an iPhone. Most of us have Fitbits or something like that. That's a lot of what we think of when we think of IoT, but the definition is evolving. Things are moving well beyond what is quote-unquote traditional IoT. So we're going to talk about the following problem as it relates to IoT. There is an explosion of IoT devices. This doesn't mean your IoT devices are exploding. I'm not here to help you with that. We're here to discuss the explosion, the ever-expanding growth of IoT things in the world. This explosion of IoT things which generate data leads to lots and lots of data. That explosion of data is data that's important to you. It's data that's generated for you, by you, and affects you. It's important not just because it's potentially sensitive, it's private information, and not just because of what it is, but also what it is not. We heard a very interesting discussion by Mr. Young, the Intel/McAfee keynote speaker, who talked about weaponization of data. So suddenly it's a whole new perspective on the security of the data, not just the privacy, but also the integrity, making sure it's not weaponized and used against you. And the crux of this conversation is to think about the journey that this data takes and all the perils as it travels between your IoT device to the services that provide the backing of that and beyond. So we should all be aware of these perils and act appropriately. So the objectives of this conversation today is we're going to start by just taking a rough stab at defining IoT, just a level set, because I bet you if you asked 10 people what IoT means, you'd get at least 2, maybe 3 different answers. Subtle nuances. We're going to explore a little bit about the data landscape. What is the data that I'm talking about? And then we're going to spend time analyzing the journey of this data through IoT and the perils along the way. And last but not least, I hope everyone can leave here thinking a little bit more about what are the next steps I can take in protecting the data as it flows through IoT. All right, so let's take a quick definition of the Internet of Things. Here's what analysts tell us the definition is. It's a noun. It's just like Merriam-Webster, it tells us it's a noun. Network of physical objects that contain embedded technology to communicate and sense, should say and or interact with their internal states and the external environment. That's a lot of words, right? It's one of these things we kind of know what it is when we see it. It's things like the smart refrigerators, smart thermostats, IP cameras, smart watches connected to smartphones, cell phones themselves, drones. All of these things are connected to the internet to generate data through sensors, possibly to actuate or make some effects, changing your light on-off state, changing the temperature. But guys, there's actually a lot more IoT out there than this traditional thing. Not everyone thinks about things like smart streetlights, internet-connected streetlights that turn on and off to minimize the power usage in a city. Gunfire locators in cities, sound sensors that detect and analyze where are shots fired so police can respond. First responders are better at responding. Agricultural irrigation systems, drill bits and hydraulic fracturing can be considered IoT. I'm from South Central Texas, San Antonio. Go Spurs, go. Fracking is big business where I'm at. And you would be amazed if you've never looked into this at how much data is generated by a drill bit boring down into the shale layer of south central Texas. Velocity sensors, rotational sensors, how fast is it going down? What's the gas flow? What's the water flow? What's the pressure at any given point? All the way up and down this, sampling at many times per second. So IoT covers all sorts of things that maybe we don't always immediately go to. So I'm going to generalize here. Much like that's a generalization, the key things we need to think about, Internet of Things, the definition is some kind of computational power, usually attached to a sensor to gather data, some kind of radio signaling to send the data somewhere. Notice I said radio signaling, not just Wi-Fi or internet connectivity. There's lots of connectivity mechanisms, either directly to the internet or indirectly. Bluetooth connected to your iPhone, which goes through cellular for IoT. Zigbee, all sorts of other radio signaling protocols, and sometimes actuators, things that make changes to the physical environment. And guys, that's what scares me the most as I'm at RSA, actuators. This luckily doesn't affect my conversation, right? We're talking about the data, not the endpoint protection. But if you have an IoT device that can make changes to the environment, think of an autonomous vehicle, can press the accelerator, can turn the wheel, man, that's scary how much you have to protect that from nefarious actors. I don't want that actuator turning my car to the left into oncoming traffic without me knowing about it. It needs to be protected. Nefarious actors shouldn't be able to do that. And luckily, that has nothing to do with data, right? Except, what about weaponized data? What if someone gets into the system and injects malicious payload into the sensor system so that the car thinks it's about to have a collision and the avoidance system says, it's clear to the left, so I'm going to turn to the left. Suddenly, the data itself is just as critical as the protection of that endpoint. Fascinating. All right, went too far. As we speak about data, let's just take a rough guess at how much data we as a human race generate. This number here is actually from a 2013 EMC survey, so this is already quite out of date. You can imagine it's a lot bigger, but I can't even think on this scale, so it's good enough, right? 2.5 quintillion bytes of data created per day. What's a quintillion, you might ask? I asked that. It's 18 zeros. 18 zeros. Again, Mr. Young in the Intel keynote talked about an autonomous vehicle generating 4,000 gigabytes of data per day. So this study came out before a lot of autonomous vehicles were out. So a lot of stuff. Here's a few more key points. A 2015 Gartner study estimates that IoT endpoints will reach an installed base of 21 billion units by 2020. It also predicts that in 2020 alone, 6.6 billion things, IoT things, will be shipped. About 2/3 of them in consumer applications. And also in 2020, hardware spending on network endpoints will reach $3 trillion. That's what Gartner predicts from a 2016 analysis. A later study predicts that 30% of cities worldwide will implement LED smart lighting systems. So let's generalize again. What are we talking about here? Lots and lots of data. More IoT devices entering the landscape. More and faster connectivity throughout the world to get that data where it needs to go. Younger individuals starting to generate data footprints every single generation. It took me a long time to generate a lot of data. I was midlife before I started doing cool things to generate data. My 15-year-old son generates a lot more data than I do with his iPhone and his drones and all that fun stuff he does. My 8-year-old daughter uses the Amazon Echo every day, which is an IoT thing that generates data. My 2-year-old daughter's not quite there yet, but she tries to say Alexa. Alexa? Every generation generates more and more data at an earlier age. And society, as you know, is moving towards socialization, instant gratification, post everything. So fundamentally what we're saying here is there's some really complex math that's above my head. This is not just algebra. This is that calculus stuff. The rate of change is growing. So this number just gets bigger and bigger. All right, so let's begin. The journey of data through IoT. We're going to start in a very simplistic manner here. We're all familiar with the journey, right? There's a device, a thing, a something that's connected to the internet. There's probably REST and JSON-based web services backed by microservices in a container and a ubiquitous, always-on cloud that does all sorts of cool stuff. It responds to the requests. We're post-Heartbleeds. We're all smart here at RSA. We know how to make secure communication channels. So SSL is used everywhere to make it secure. And information moves to the cloud or to the vendor, the service provider, from the device, possibly through an intermediary like your iPhone. And often it moves back again. So this is a pretty simplistic view of the journey. What about the data flowing through there? It's really important to us as consumers and to the businesses that we represent that we are concerned about the data flowing through it, not just for privacy reasons, but also for integrity reasons. Things in IoT that we often think of with the data is the location awareness. That data gets sent all the time. Payment information, often associated with IoT devices or services related to IoT. Behaviors. Where did I walk? Where did I drive? Where did I Uber? What did I buy? Which credit card did I use? Further, IoT is just one of the many avenues that we use, and it's a growing avenue, a growing footprint of how data is generated, and there's a lot more now, and how it's moved. There are perils along this journey of data that we need to be aware of, that we need to be able to manage effectively. And guys, I hate to tell you, it doesn't start when you open the box and you connect your device to Bluetooth or Wi-Fi. The famous ancient philosopher Lao said that the journey of 1,000 miles begins with a single step. Allow me to bastardize that, please. The journey of your data through IoT begins with 1,000 steps. By the time you open that box with whatever that cool new device is, there are things that happen to get it into your hands that incorporate numerous perils. So what might it be? What was the design and inception of that device? Was it really a well-contemplated, brilliantly designed piece of hardware and software that offers services to you, the consumer, or the business? Or was it, holy cow, I've got an idea and I need to get it out as fast as possible using the cheapest supplies possible in order to win first to market and to get some amount of money out of this? I would contend that a lot of IoT, being a young nascent market, is the latter. What about the economics around this? If you haven't noticed, and there are a lot of speakers talking about this, it's a very competitive marketplace. IoT devices have to necessarily be very cheap. I can't sell someone a device to monitor the agricultural environment of all of their fields and every row of their plantation so at $100 per unit. It's got to be really, really cheap. Now the good news is suppliers are creating cheaper and cheaper components. I can get a Raspberry Pi for $35, our next thing chip for $9, or an Omega 2 chip with all the wireless communications built in for $5. It's really, really cheap. But that's not cheap enough. I have to account for RAM and CPU and power, and are there corners that are cut along the way to get me that device at the market-bearing price that cause some problems? For example, does it have enough memory and compute power to do SSL encryption the right way and to manage certificate authority revocation, et cetera? What about the supply chain? Where did this stuff come from that gets composited into the IoT device? Have I properly vetted the Chinese manufacturer that puts together the boards? Do I know if the silicon is safe and secure? Do I understand the architecture of that stuff? Has the software supply chain been vetted properly? Or am I just pulling together all sorts of components? I happen to be more in the software world than the hardware world, so that kind of scares me. There's a lot of latent defects in open source software. But a lot of IoT is based upon the cheapest way to get something done. So you pick up open source software, you graft it all together and hope that it works. Is there diligent QA put into all sorts of security testing? Probably not. What about the engineering of the framework? So this goes to the underlying software, and not just on the device, but also in the cloud. The backing of those services, the IoT things. Has there been adequate engineering effort put into that? Validation, security testing, static analysis, dynamic analysis. All of this stuff leads to the device that you just bought and you're connecting to your internet via your Wi-Fi router. It's kind of scary. And then last but not least, lack of standardization. It is kind of a free-for-all right now. And the respected cryptographer Bruce Schneier has a lot of good discussion points these days, both at RSA and in his blog, about the need for regulation. The market forces alone are not causing enough of an environment to keep these devices secure so that they're properly managing your very sensitive data. So there probably needs to be something done regulatorily. That's hard for a Texan to say, sorry. Need them government in there. You're going to need some help. Just like automobiles, in order to ensure safe travel for all of us, had to get some kind of oversight to ensure some minimum level of safety standards. We might have to engage in some kind of regulatory agencies or incentives or disincentives to make IoT safer. But fundamentally, when we think about the data, you really have to look at the functionality that's provided. Is this a health monitoring system IoT that you wear or embed inside your body? Is this just a cool, fun drone that you're using to survey a landscape? Is it agricultural systems, et cetera? It's the functionality that really describes the blueprint of the journey that things take. All right, so let's walk through the journey. Well, Greg, I thought you were going to do that 15 minutes ago. Sorry, here we are. We had a level set first. Everything leading up to it has challenges, but now we're at the point where the data flow actually begins. So I've scared you about everything leading up to opening the box, but now that you've connected the box, you've opened the device out of the box, you've connected it. What happens? You establish some kind of internet connectivity. This could be direct to the internet via your Wi-Fi or cellular data, or it could be indirect. Bluetooth, borrowing the signals of your iPhone or your iPad or some kind of Zigbee board in your house or industrial systems. There's authentication, hopefully. At some point, you want to make sure that only the right privileged individuals can access the data and or generate the data, or that the consumption of the data at the service provider is properly authenticated and tied to your account. There's the need for secure channels between endpoints. Again, we're pretty good at SSL, but we're good at SSL in commercial-grade computers. Are we good at cryptography in low-power, highly constrained IoT environments? That's an interesting question. But this is the data flow. What are some potential perils as we think of this very initial journey? Well, unpatched systems. Most of us are aware that when I buy a computer or I buy a DVR, hopefully it's already out of date, so I need to apply firmware patches or software patches. Do we have that same level of diligence with IoT? We should. Weak passwords. Man, we've seen lots of exploits around weak passwords. The whole Mirai thing takes advantage of weak passwords or default passwords. So this is a peril. We need to be aware of it. We've talked about the compute power and memory constraints that inhibit security. Maybe that CPU is really, really cheap and it can't do 256-bit SHA-2 hashes very effectively or 4096-bit RSA encryption properly. So it's downgraded to something a lot less secure. Maybe. Do we know that? Have we looked into that? And as you connect more things to the internet, your attack surface is larger. So the data that's being generated and flowing through all of these systems necessarily, all those avenues necessarily open up more points of peril. That's step one. Step two, the journey continues. Where does the data go? How is it used? The data from your device, IP camera for example, arrives at some vendor or service, typically through a cloud provider. It doesn't always have to be that way. The data is typically processed for immediate needs. Alexa, what's the weather like? Okay, Google, how's my drive? Immediate processing, data flows up to some service provider, some information flows back. The data is probably stored for subsequent use. Might not be your use, might be the vendor's use or the service provider's use. But we have to imagine that it is stored for subsequent use. So for example, once I order an Uber from my Amazon, and I engage in that on my Echo, my Alexa. I'm sorry, I have an Echo, so I use that a lot. Just insert Google Home or whatever else you use there. When I order that Uber ride and I complete my journey, let's think about all the people, all these services that were involved and where that data might reside. Amazon has my data. Uber has my data. Google Maps has my data. Some payment processor has my data. Maybe even some charity has my data. Apparently you can donate to charities through an Uber ride. And all of them can mine it for their own needs. Have you checked every single privacy policy and disclosure policy and integration policy with every single one of your service providers? Should you? I would recommend it. And if you're the steward of your company's data, you should. So what are some potential perils as we think of this portion of the journey to some service provider and across multiple back-end services? There's a lot of services here that must authenticate. On the one hand, I don't want to have to enter my password for Amazon and Uber and MasterCard and Google Maps. So I want the convenience of doing it all at once. But where do I put the trust for the proper authentication of back-end services? How do they delegate or federate trust? Are there challenges to authentication? How about privacy and the risk of compromising privacy? If I store my information in Evernote, are they going to be able to read it? Well, for a while they were, but then they went and changed it, right? Because someone raised a stink. If I'm ordering a Lyft to meet this nice lady that I happen to run across on this website, I don't know if y'all have heard about it, but Ashley Madison, a lot of nice ladies there. How is that data protected? How is that data kept secure, private, so that others don't take advantage of that? Or imagine, if you will, the weaponization of data as well. What if I'm a completely innocent person and someone's trying to blackmail me and they inject false data into this whole scenario because it's insecure or doesn't have proper authentication, or one system on the back end is compromised? Can they then blackmail me and say, I've got verifiable proof that can be held up in court that you did visit someone from Ashley Madison via Lyft? And what am I going to do? So it's important that we are aware of the perils of privacy compromise, not just accidental, but malicious as well. And the more participants, the greater the attack surface. So bad guys love it when you have a lot of systems involved because they just need to get into one. So how can we mitigate some of these potential perils? Good password management across all services. Monitor your access and usage. Most services provide a way to determine who's accessed it when. When was the last time you did it? What did you do? Come up with a monitoring system. Just like your IT operations folks monitor your networks, monitor your IoT usage. Always review your vendors' policies, end user license agreement, privacy statements, etc., so that you're aware of what's happening. Only allow access where you fully understand it and you want it. Stop blindly turning on, okay, I'll allow all of this access. And like the good cybersecurity warriors we are, assume that there are adversaries out there. And tailor all of your operations around IoT, whether it's personal or business related, assuming there are adversaries. And here's one recommendation I'll make. If you're concerned, whether it's cloud services or IoT-enabled data flow services, you really ought to be doing some kind of risk assessment and cataloging of information. It might be okay for your credit scores to pass through some IoT device because if someone leaks your credit score, it's embarrassing, but it doesn't harm you. But your sensitive medical record information, which affects your well-being or your mother's well-being, that's probably a lot higher risk. So you need to take a little more caution in that. So we all need to be inventorying and analyzing the risk associated with our use of systems, including IoT. All right, but guys, the journey continues. Look at this complex interaction of services and devices throughout the world. It's actually this big circular journey, if you will. It becomes convoluted very quickly. It only becomes more so as more devices and services are offered and interconnected. And guess what? Even those interconnections generate more data. So as we're looking at the data-centric approach, I order that Uber to go eat some food. It's tracked through Maps and Amazon Alexa and all that kind of stuff, but then they generate more data for behavioral analytics, predictive analytics. That data then might get shared across back-end systems. So it's not just one level deep of generating data, it's multiple levels. And it's all in this big collective communications network. Some of those interconnections, I have no idea what they are. The vendors do, the suppliers do. This complexity foretells of many future cyber attack characteristics that we're already starting to see some of. Think of Mirai taking advantage of IoT vulnerabilities in DVRs or home routers. It's the complexity of the interconnections and the lack of understanding by consumers and businesses on how those interconnections affect not just their business operations or home operations, but also the rest of the world, which lead to some of these problems. As a consumer, I don't care if my router is compromised as long as I get to watch my Netflix. The router vendor doesn't care. He has no skin in the game because he's already captured your money. The fact that someone's exploiting your DVR or your router to launch distributed denial of service attacks, there's not enough skin in the game for consumer or supplier. But that's kind of the risk. Imagine that not only IoT devices can be compromised, but also service providers. So as we take a data-centric approach, I shouldn't just be concerned about the cybersecurity strength of IoT devices, but all components through which data flows. So for example, that Nigerian prince doesn't just have to send you an email anymore to try to get your money. If he can somehow work with the data that gets your Amazon Alexa to interact with the Amazon purchasing store to do something with the credit card payment you have on file, he can get his money prime shipped to him. There's a lot of complexity involved. Another risk here, or potential peril, is abusing the trust in services. If anything is compromised, if any failure occurs in here, how do we isolate which service it was that failed? Does the inappropriate use of my Pandora account, so I get some notice from Pandora saying you're using this wrong, what do? Do I stop trusting Pandora? Do I stop trusting the system in my car that leverages Pandora? Do I stop trusting my computer or my iPhone? If my Snapchat spectacles start taking pictures when I didn't initiate it, is that a problem with Snapchat? Is that a problem with some service provider on the back end? Is that some interconnection back here? So suddenly it's really hard to pinpoint, and I don't know who to trust anymore. It becomes a pretty scary world. The loss of service is another potential peril. As we rely more and more upon these interconnected services, any one service could cause problems. If a payment card processor has some kind of challenge with the data flowing based upon my smart hub refrigerator, and I don't get my bacon ordered, that's kind of a problem. It's a loss of service. I don't get to eat my bacon in the morning. But is that really a big problem? But what if the payment card processor fails to reorder the life-saving medicine that I need? That becomes a problem. The data flow might itself have been interrupted, or it might have been maliciously subverted. So the flow of data and the loss of service around that data is very important, and it could be perilous. So how do we mitigate against some of these challenges? First of all, it's awareness, right? So you guys are more aware, if you weren't already, of all the complexity and interconnection. Maintain that awareness. Keep up with the industry. Pay attention to articles, privacy policies, etc. Secondly, avoid critical dependencies where this risk occurs. So don't just let your IoT systems, your Amazon Tap, reorder that life-saving medicine And if something fails, you're dead. Have backup plans. Assess the risk of the thing which is associated with IoT and the data flow throughout, and give yourself an opportunity to recover in the loss of service. Sounds an awful lot like what IT operations has dealt with for 20 years, right? Backup plan, disaster recovery plan, et cetera. You'll see it's a lot of the same stuff, just applied in a different perspective. All right, so Greg, you're boring me. All this is theoretical and abstract, and I don't believe your things about Ashley Madison and Uber. So let's talk about some real-world examples. Philips Health offers a wonderful service. Homes, I forget the actual thing, I'm sorry, but you can see some of the complexity involved in a system that allows people within the home to have a series of interconnected IoT things. And this is all available on Amazon through this hyperlink. Sensors for heart rate, sensors for temperature. Is the water flowing in your house? Is there a leak? What is the, there's some kind of voice control. There's the pendant. Help, I've fallen and I can't get up. All these things routing sensor-based information through a gateway connected to the service offering hosted by AWS. So Philips provides an awful lot of really cool services around all of this sensor data. No green laser. Red laser doesn't work. That service provider, that's fine, I don't need it. That service provider layer, all the cool stuff that they charge you for, the business logic they put into it. Oh, he got it to work. I tell y'all I'm a Texan? It's got one button. Woo! So this, Philips provides all these wonderful services atop an awful lot of AWS services. S3, Glacier, Lambdas, all sorts of EC2 hardware, etc. And then down here we have family and caregivers, maybe doctors, health providers. You can also imagine this extends to specialists reviewing x-rays or whatever. This is a real-world example of all the complex interrelationships for one service that Philips provides. Is my mom doing okay at home? She's got, starting Alzheimer's. Or maybe somebody needs some special assistance. So I need the caregivers and myself to be able to monitor them. All these sensors generating tons of data all the time, flowing through a cloud provider, integrating with lots of different systems in the cloud and at different premises. The data flow generates mineable, actionable intelligence. Where is it stored? How is it used? How are they authenticated? What happens if a service goes down? All of these things represent the perils in a real-world scenario. Here's a completely different take, another real-world scenario. This is from a company, Labellium, and I know it's really too small. Y'all can look at the PowerPoints afterwards, but this represents the vast array of IoT things that maybe we don't think about and the complex interactions of potentially life-saving or life-threatening data flowing through the IoT system. You've got bridge sensors, nuclear power sensors, smoke alarms, sound sensors for urban noise and or gunshots. You've got traffic flow sensors. You've got all sorts of sensors across this city or this residential district that can all work together to create a harmonious place to live. An optimally efficient, low carbon footprint, minimizing the power expenditure. All of these great things, reducing traffic patterns that cause people anxiety and making the world a better place to live. All of these things interacting across so many different sectors of public safety and well-being. All the data generated and integrating with lots of different systems. All of the perils we mentioned exist in full relief here as you consider these systems interacting with each other. All right, so I want to get to the point. I'm running out of time, so I want to quickly go through these and get to the point of what can we do about this. So one last thing, that's the end of the journey, right? We have this really complex system. No, it's not the end of the journey. You have to ask yourself, does it ever really end? Because data itself that gets generated is never transient. It doesn't just go away. What happens to the data that you generate through the history of your life? Does it become this dark data, the unstewarded data that exists somewhere out of your control? How is the data mined for behavioral analytics? The more data you generate and it's stored, never really deleted, because it's out of your control, you're not the one deleting the data. It's the service provider. There's an increased opportunity for data breach. It's a richer field for people to plunder. And maybe the risk-reward metrics cause somebody inside to do bad things. Right? So I'm a very good steward. I'm an honest, open citizen, but man, there's so much opportunity here I see in front of me with all this wealth of data. I know exactly where everyone walks every day because I'm mining the Niantic Pokemon Go database, and I could sell that to bad guys to go into people's houses and steal stuff. So maybe that internal risk-reward calculation tips, and they sell it. Vendors using data in nefarious ways. Might be overtly or maybe minorly nefarious. Your smart TV capturing what you're watching and selling that data to other vendors, advertisers, etc. It's in the privacy policy. It's not strictly nefarious, but when they hide it, do we really know it? So guys, the journey never ends. So let's bring this back to reality here. Let's talk about numbers. $1 billion. Gartner has predicted that in 2017, in this one it's by 2022, again, that same survey, Gartner predicts there will be several significant IoT product recalls. Product recalls. Not breaches, not nefarious use, product recalls that result in a $1 billion cost due to faulty IoT implementations. That's a lot of money. Someone's got to bear that. A Pragmatic Strategies report in 2016 suggests that there will be a 50% increased cost in industrial IoT for security due to attacks on critical infrastructure. We have to secure these things. It doesn't come for free, so the costs are going up. That's borne by the taxpayers, typically. 500,000. Forrester predicts that in 2017, more than 500,000 IoT devices will suffer a compromise, dwarfing Heartbleed. We thought Heartbleed was bad. Heartbleed demonstrated an inherent flaw or challenge in using open source software, but we've already said that the economies of IoT drive people to open source hardware and software. And there's a proliferation of devices, and we all want that cool new thing, so this is a challenge. All right, so what can you do? Well, first of all, go to RSA and listen to me talk, because that's great. You are now understanding the challenges better than ever before. Even today, you can start writing policies and procedures to protect you and the enterprise that you represent. These policies and procedures are analogous to what you've already done for the recent bring your own device or BYOD thing, right? That was a big craze and we had to deal with it. How did you deal with it? You understood the problem, you wrote procedures and policies, and you enforced them. Things like assessing the challenges, managing the devices, providing audits, doing data classification and DLP, making sure you had physical security around those devices, changing default passwords, having a mechanism for applying patches regularly. All those things are important policies and procedures. You should make sure you monitor and manage your IoT footprint. Don't let it just sprawl out of control and deal with it later. And I recommend you immediately establish a procurement process that ensures you are fully aware of the path that the data takes through the systems. Where is it shared? How is it used? What is it governed by? What are the remedies you have in the event of a breach? You can do that today. Nothing's stopping you. And then, in 3 months from now, looking short-term future, guys, learn from history. The recent HVAC or pacemaker attacks should raise your awareness. Wow, that could affect the IoT I use at home or in my business. I remember when that thing happened back then. I better inform my decisions today based upon what's happening yesterday. Make sure you have an enhancement to your training or education awareness, just like you did with BYOD. Don't assume that the people you work with know what they're doing. Help them understand the risks and perils. Assess and catalog the risk. We've talked about that. And then this is my favorite. Get involved in making changes. Write your congressman. Are there any consortia or standards bodies that exist today around IoT? Why don't you join them? Why don't you propose some standards or security? You guys are all the experts in cybersecurity coming to RSA to learn more. You could also contribute back and help us all get better at the regulations or mechanisms by which we benefit from increased governance, or security or standardization of IoT. All right, so let's review. We said we were going to define IoT. We're going to better understand the data landscape, analyze this pervasive and perilous journey of data through IoT that never ends. We're going to offer next steps. So now, we're done. For a Texas boy, you sure talk a lot. I have about 5 more minutes for questions if anyone has questions. Thank you again. Please do fill out your surveys because you can win some cool stuff. Yes, ma'am. You can use microphone or you can yell.
Oh, I can yell. Okay.
Yeah.
I don't know if you touched on this, but do you see a role for blockchain or distributed ledger technologies?
I am not expert enough to say definitively, but blockchain does provide a lot of interesting capabilities for ensuring some security and privacy, but I personally have some concerns around the voting process or the unanimous election versus partial election. So I think there's still some things to work out there. But I'm all for anything that allows a collective to agree on a protocol to better secure everything along the way. So unfortunately, that's the best I can answer. It's kind of vague. Sorry. There's some blockchain experts who could probably answer it better than me. Yes, sir. Yeah, so dark data is a term that has been coined. I know it's been used by IBM and others that refers to just this proliferation of data, the fact that it doesn't have retention policies or erasure policies. We're generating so much more data. Do we really know what's going to happen to it? If I have 5 years of my viewing history of Amazon Prime videos stored in some server and accessible not only by Amazon but also by the service provider ABC and CBS, is there anything they can do to mine that data for behavioral patterns or for anything that would allow them to gain benefit? Sometimes it's completely innocuous. They know what advertisements to sell to me. Sometimes it's to my benefit. They know that most people watch these shows, so I'm going to renew that show, which is good for me. But with all of the proliferation of IoT and some of the sensitivity of the data flowing through it, I would just pose that without proper retention and expiration policies of data, or without, for example, GDPR, the new EU regulation they're working on that allows you to have the right to be forgotten, that unless you have some control over all that data and what happens to it once you relinquish that data, there's a possibility it could be used in ways that might not be how you want it to be used. I love that right to be forgotten, by the way, but I'm wondering how it's really going to be enforced. Are you going to audit systems? Is there some remedy that allows me to do analysis? It's like PCI audits, or anyway, it's fascinating. All right, guys, again, thank you very much for spending time with me. Fill out your surveys.